policy recommendations to our governments is a core OECD mission. This not only requires foundational data, but clear methodologies, definitions, and taxonomies. This is at the heart of our work. It's reflected in the International Programme for Action on Climate, or IPAC, whose focus is on coordinating and developing climate change indicators. And as part of this work, we're committed to the development of consistent and harmonised indicators. And we all know effective climate action is the only basis for achieving the Paris Agreement goals. But doing so means overcoming several significant challenges. Most importantly, as many of you are well aware, there is first an ambition gap. In other words, the emission targets on the table today are not ambitious enough to achieve the 1.5 degree Paris Agreement objective. And second, there's an implementation gap, because even these targets may not be achieved since climate action has not been as effective as it needs to be to date. To help address these challenges, there is increasing demand for consistent and harmonised climate policy data. The ability to track the evolution of both policy adoption and policy stringency facilitates analysis. It allows us to compare different approaches and helps assess effectiveness. However, as yet, there has been no consensus on how to measure countries' climate actions and policies over time, and therefore there's insufficient data to enable measurement. To help fill this gap, the OECD has developed a database called the Climate Actions and Policies Measurement Framework, or CAPMF. This is a climate change mitigation database that monitors climate action by tracking 130 policy variables across 50 countries over time. As of now, the CAPMF covers a 32-year period from 1990 to 2022. And compared with other climate policy databases, the CAPMF is unique for two reasons. First, it is harmonised to the extent that it tracks the same 130 policy variables for all countries across time. Second, it comprises information on the stringency, or perhaps it's better described as the intensity of climate policy. And without this measure, it's impossible to adequately track the evolution of countries' climate action beyond policy adoption. In other words, to encompass the evolution of implementation. So let me also say that the CAPMF has already been used in numerous applications at the OECD, as well as in other international organisations like the World Bank and in academia, for example, by the Potsdam Institute for Climate Impact Research. Now, we're very fortunate that both the World Bank and Potsdam representatives are here with us today, and we'll hear from them a little later. However, we are still on a CAPMF journey, and there is definitely room for it to be improved and adjusted. Our hope is for the CAPMF to become a global reference, and to achieve that, we must be, and we are indeed, willing to put its methodology up to scrutiny. So we are therefore delighted to have speakers from our Economics Directorate, the Potsdam Institute and the World Bank with us here today. They're going to present and discuss their empirical applications shortly. So before that, I do want to hand over to my colleague, Daniel Nachtigall, who will provide more details on the CAPMF's policy scope and methodology. So many thanks, and I wish all of you attending an interesting and enlightening webinar. I don't know if I'm going back to you, Elisa, or direct to Daniel.
Not sure. Well, thanks a lot, Joe. That was a very nice introduction, and thanks for explaining also how the CAPMF work fits in the wider work of the OECD on as related to IPAC, for instance. So yeah, back on to you, Daniel, for the presentation. Thanks.
Yeah, many thanks, Elisa. Can you see my screen?
Yes, we can see.
Okay, perfect. Yeah, so hello everyone, and many thanks for the nice introduction, Joe and Elisa. What I would like to do is to present a little bit the challenge of how to measure climate action and how do we do that actually in the CAPMF, the Climate Actions and Policies Measurement Framework. Before I start, however, let me just briefly mention that, or really highlight that kind of all the work is really the result of a huge collaborative efforts with the colleagues that you see listed here in the title slide. And it actually also goes beyond. I mean, there were many other colleagues that have been also doing really an amazing job in the last 3 years to bring all that data that we have collected together. So what I'm going to do in the next 20 minutes is to first discuss a little bit how to measure climate action and how do we do that precisely in the CAPMF, and then present a few applications and use cases, not too much into detail because that will be also covered in the next presentations, and finally some concluding remarks and outline for future work. So how to measure climate action? So I think kind of just going one step back in terms of motivation. As Joe mentioned, so effective climate action is really critical to achieve the goals of the Paris Agreement. And so policymakers need and want to know which policies work and which do not. And that is actually kind of the major focus also of the next forthcoming IPCC report. So there is currently like a proposal to create what is a so-called evidence bank, an evidence bank of climate policies that policymakers can draw from. And as Joe mentioned, to provide or to create this evidence bank, we really need to have the foundational data on climate actions and policies. And currently, there is a major gap in that climate policy data, and the OECD aims to fill this gap. So both with the Climate Actions and Policies Measurement Framework, but also with an OECD stock-taking exercise under the Inclusive Forum for Carbon Mitigation Approaches more broadly. So before going into detail, maybe let's step a bit back and ask, so what is actually really climate action? So a rough definition could be that essentially it's all actions that can be expected to directly or indirectly reduce greenhouse gas emissions. So that simplified chart here shows that government's climate action usually triggers a change in behavior, so usually private action, and that then leads to change in outcomes, for example, economic or environmental outcomes. And then based on these outcomes, they feed back again into government actions, because if the outcomes are not as expected, then the government needs to refine. So I think what is really important here is that the scope of the OECD work on stock taking is really concerned about government's climate action. And the reason for that is that we do not want to confuse inputs, so the action of the government, with outcomes like greenhouse gas emissions. And that actually has quite important implications for the interpretation of all of the results here. So for example, if we look at our stock taking work, then it essentially means that we are not directly measuring effectiveness or any other outcome. However, what we are doing is to really provide the foundational data to assess effectiveness of policies or the effects on other outcomes. So that is the first caveat. The second one is, what would we actually like to measure in an ideal world? So, I mean, the first thing that comes to mind as well, we would like to be all-encompassing. So what Joe was mentioning, going towards all countries, ideally all levels of governments, covering more than the 32 years that we have, covering essentially all years. But the more important question is actually, so what do we actually really mean when we say measuring climate action? And in our view, climate action has at least two key components. So the first one is the type of action, so more or less like the what. And the second one is the stringency of the action, so the how in a way. So let me first start with the what. So in a way, we would like to measure all key climate and climate relevant mitigation actions and policy instruments. And I think two things are important here. So the first one is that we would like to go beyond climate policies and also include climate relevant policies. So these are policies that do not necessarily have as a primary intent to mitigate greenhouse or to reduce greenhouse gas emissions, but they still have a material effect on emissions. So, for example, fuel excise taxes or air pollution standards come to mind in that category. And the second point is that we also would like to go beyond policy instruments. So we also want to include other actions like target setting or climate governance, both of which can also have a material impact on greenhouse gas emissions. So the more interesting question is actually the how. And here, I think it is certainly not enough to only look at the adoption of policies. So we need to also have information about the stringency or the intensity of climate policies. Because the stringency essentially also determines at the end how effective or how demanding a policy might be. So what I mean essentially is that a carbon tax, for example, so we would like to have the carbon tax rate that needs to be sufficiently high or a standard that needs to be sufficiently demanding. So, and of course, I mean, all that is very demanding to measure, and it is probably also impossible. So, but as a first step, we developed the CAPMF. And what do we measure with the CAPMF? So in terms of country coverage, we have 50 countries, OECD countries, G20 countries, and OECD accession countries. And these 50 countries cover more than 60% of global greenhouse gas emissions. And then we have, usually we focus on national level legislation, but we also have some selected subnational instruments. In terms of time period, we are covering 1999 to 2022. And in total, we cover 130 policy variables, which we group into 56 policies. And we cover 70% of instrument types that are listed in the latest IPCC report. And it's important to say that we go beyond policy instruments. We capture market-based instruments, non-market-based instruments, but also other actions like climate targets. And we also cover climate and climate-relevant policies. So on the policy stringency, yes, we cover policy stringency, but we do not cover information on enforcement or on design or on emissions coverage. So all that is can be part of the bigger stock take under the IFCMA. So I think the bottom line here is essentially that yes, the CAPMF is still not all-encompassing. It is a first step to measure climate action, and we are about to improve both our coverage and our methodology once we go ahead. So let me walk you a little bit through the policy scope of the CAPMF. In principle, we have three big building blocks, what we call them: sectoral policies, cross-sectoral policies, and international policies. So for sectoral policies, we cover the four big energy sectors: electricity, transport, buildings, and industry. And between them, we distinguish between market-based and non-market-based instruments. So market-based instruments, we have, for example, carbon pricing, so emission trading schemes, carbon taxes, also fuel excise taxes. But then also some subsidies, for example, subsidies for renewable energy support, feed-in tariffs, auctions, and so on and so forth, congestion charges. On the non-market-based side, we have technology standards such as bans and phase-outs, but also performance standards, for example, air pollution standards, or information instruments like energy labels. So on the cross-sectoral policies, we do have, for example, information on greenhouse gas emission targets, public RD&D expenditure, fossil fuel production policies, and climate governance. And then finally, on the international policies, we have information on international cooperation, international public finance, and also greenhouse gas emissions data and reporting, which is linked to international agreed reporting standards. So then the problem is, or let's say for each of these actions and policies, we do have the underlying information on policy intensity. However, the problem is that most of these intensities actually have very different units. So some are measured in terms of tax rates, others in emissions limit values, others in expenditures. And that essentially really prevents us from aggregating different instrument types into into useful policy categories. So, for example, it is not easy to just make statements about how did climate action evolve by and large, or how did climate action of market-based instruments compare to non-market-based instruments, and so on and so forth. So the solution to that problem is essentially that we normalize the very different units to translate them into one common unit. And we do that by using a methodology that is based on the OECD environmental policy stringency workstream, and which essentially is also quite widely used in indicator development. So let me show you one example of a carbon tax. So here we see the carbon tax rate in US dollars for different countries in different years. So each of these small green bars essentially represents one country year entry of a carbon tax in our database. So what we do in the first step is that we order the intensity values from lowest to highest. What we then do is that we split that data mass into 10 equally sized intervals, and then we assign a stringency score of 10 to the highest, to the top 10%, and then a stringency score of 9 to the following 10%, and so on and so forth. And the lowest 10% will get a stringency score of 1. And finally, all country years that do not have a carbon tax in place will get a stringency value of 0. And we do that not only for carbon taxes, we also do that for all other variables. So all other policy variables have the same unit. So just to say that here we have like one example for metric variables. If we have binary variables, for example, we would assign like a 10 if the policy is in place or if the condition is fulfilled, and a 0 otherwise. And for categorical variables, we would map in a way like the different policies into the space from 1 to 10. And that intensity values or these stringency scores really allow us to aggregate and to make kind of more bird's eye view statements if you want to. And just before I provide a few examples, let me just also mention where the data comes from. So most of the data actually comes from in-house, from the OECD and the IEA, also partially from the International Transport Forum. But then we supplement the data with data from other international organizations, so the World Bank, UNFCCC, UNSD, IRENA, ICAP, and ICAO, for example. And we complement that data with desk research where possible. So let me go to the applications and use cases. So that graph here actually really answers the question, how did climate action evolve over time? And so we see that climate action actually increased between 2010 and 2021 on an average by 10%. And we can actually see that the origin of that increase is both. I mean, first, countries adopted new policies, so the size of the bar gets bigger. But then second, also countries increase the stringency. So the size of the green bar and the yellow bar, which indicates high and medium stringency, also increase. So that development we could see in between 2010 and 2021. However, if we then look from 2021 to 2022, we see that there's actually only a very slow growth. So climate action really slowed in 2022. And that was actually like the key message of the last IPAC Climate Action Monitor. And at the moment, we are getting the data for 2023, and we will see how that trend continued in last year. So what we can also do is to see what have been like the drivers of the growth. And here, for example, that chart shows different instrument types, the climate action of different instrument types, and climate action is calculated as the average policy stringency across all policies of that instrument type. And we can see that most of the growth actually comes from climate actions that are related to targets, governance, and climate data. And that is mostly driven by the implementation of the NDCs, but then later on also increasingly uptake of net zero targets. Then we see, if we see at the red line, we also see that non-market-based instruments saw some growth. And then the blue line, there we see that actually there was quite slow progress of market-based instruments. So then we can also zoom into market-based instruments. And so the first thing that we see actually is that climate action of market-based instruments in between 2010 and 2022 grew by 32%. And what we can do is we can decompose this growth into policy adoption and increase in stringency. And when we do that, we can actually really see that most of the growth for market-based instruments is really driven by increased stringency and not by policy adoption. And that actually really highlights the importance of having information on policy stringency. And that is probably also one of the key advantages of the CAPMF. So if we look only at policy adoption, we would actually significantly underestimate government's climate action by and large. I think another important feature of the CAPMF is really that we have a lot of information on non-market-based instruments. So here we see the evolution of different types of non-market-based instruments over time, and we can also see that they are becoming increasingly mainstream. And one interesting finding that stands out is that in particular in the last years, the increase in the adoption of non-market-based instruments was particularly driven by technology standards. So countries who have increasingly implemented or adopted bans on the construction of coal power plants or even phase outs. And then we can actually also go into the raw data of specific instruments. So here we have, we see the minimum energy performance standards or MAPs of electric motors for selected countries. And so on the y-axis, you don't have the stringency score. You really have like the International Energy Efficiency class, which is a stringency metric in a way, the underlying stringency metric. And what we can see is that countries actually increase the stringency at very different speeds. So if we look, for example, at the red line at China, then we see that China started to implement MAPs in 2007 and then very slowly increased the stringency over time. Whereas if we look at Europe, so the green dotted line, then we see that the European Union implemented MAPs only in 2010, but then quickly ramped up the stringency. Finally, country-specific work. So this work is based on the recent economic survey of Romania. And we see actually that Romania, compared to OECD countries, puts less emphasis on market-based instruments in the whole policy mix. So one of the recommendations that our colleagues did was that Romania could better embrace market-based instruments. So finally, as Joe mentioned, the CAPMF is used already widely. So it is used within the OECD in economic surveys and environmental performance reviews, also in some analytical works that Filippo will present in a bit. And then it is used in academia, in international organizations and think tanks, and also in business. So let me conclude and lay out a little bit the future work. So what we plan in the future is to definitely improve the CAPMF, both in terms of scope and in terms of methodology. So in terms of scope, we are planning to expand the policy scope to other sectors. So the agriculture, forest and land use sector is our key priority. But then we are also looking into policies of circular economy. We are also looking into expanding the policy scope or the instrument scope. So financial support mechanisms, for example, voluntary approaches. And then we also start to looking into more countries, so expanding the geographical scope for Southeast Asia or Latin America or Africa as well. So in terms of methodology, there have been some concerns on our methodology to calculate stringency. So we are at the moment we are also revisiting the methodology to calculate our stringency scores, and yeah, that is the work that is going on. And finally, the last pillar is analytical work. So here we have some policy diffusion and network effects that might be one option, and then also in general, the environmental effectiveness of climate policies, potentially in collaboration with other stakeholders. So finally, let me conclude. The CAPMF is a climate mitigation policy database, and the two key purposes is really to first track government's climate action over time, and also enable analytical work that then can inform evidence-based policy recommendations. The value added of the CAPMF is twofold. So first, it is actually the only database that provides consistent and coherent climate policy data to the extent that it really tracks the same policies across countries and time, which makes the data comparable. And the second one is that it's the only database that has information on both the policy adoption and the policy stringency, and both of which we would argue are key determinants of climate action. And finally, all data is publicly available. So we have over 380,000 data points on climate policies that can be used by anyone in the world and that can be downloaded from the OECD Data Explorer. And we hope that that data will also be used to feed into the evidence, or the so-called evidence bank, for example. So with that, I'm handing over to Elisa, and many thanks for your attention. And looking forward to any questions that you have.
Thanks a lot, Daniel. That was a very nice overview of the database as well as some of the applications. There was actually quite a few questions for you in terms of clarification. So one question that we received from two people is on the scale for normalization. And how it changes over time. For instance, how does it work with a carbon tax that changes over time? And whether there are any plans to include a policy stringency scores based on the year, so as to compare the relative stringency for each year. Maybe I'll let you answer to this one, and then I'll go on.
Yeah. So let me answer to the first question. So these are very good questions. And yeah, I mean, the first one is, yes, in principle, you're completely right. So whenever we would add new data, let it be a new year or let it be new countries, that automatically would shift the underlying distribution of the policy stringency scores. And then we would kind of have different scores for different editions of the CAPMF. So for that reason, what we are planning to do is that we essentially hold the thresholds fixed for now, and kind of add the new data and puts the new data into the already determined thresholds. And that we can probably do for a few years, let's say 5 years or so. But then afterwards, we would probably run the whole methodology again to reassign the scores, not only for the new years, but also for all this, for the entire historical series. So that's the answer to the second question, and to the first question. And the second one was, can you remind me again? Sorry.
One other question is whether you are also including, or how you think you might include, rural communities.
Yeah. I mean, we are at the moment, we are at the very beginning to extend the policy scope of the CAPMF. And to that extent, yes, if there are policies that are specifically targeting rural communities, I mean, that is certainly within scope. But I think it's kind of, again, important to really distinguish between input and output variables. So yes, if it is a policy, we include it, but if we don't want to mix kind of the effects of that policy.
Yeah, that's a very good point. Also, do you have any thoughts on how to include uncertainty in this type of database?
Well, that's a tricky question. So, I mean, in a way, the database that we have is backward looking, and so maybe so that is really so in a way, kind of everything that is included has already happened. So I think kind of to that extent, uncertainty if we talk about policy uncertainty, so policy uncertainty per se is probably not necessarily part of the scope of the CAPMF. Having said that, I could imagine that the CAPMF, the data as such, can probably be used to shed some more light into policy uncertainty.
All right, maybe one last question, and then we'll move on with the agenda. So policy stringency doesn't necessarily mean that a policy reduces greenhouse gas emissions effectively. Is there future work that is possible to evaluate this linkage between stringency and emissions reductions, or to test how effective policies are in reducing emissions?
Yes, so yeah, I mean, so first of all, it's right. So we are not, so policy stringency does not measure policy effectiveness. So that's certainly true. And we are not claiming to do that. There is probably like a positive relation between a more stringent policy and everything else equal, more effectiveness. But it really depends at the end on the country context and on, kind of the conditions, the economic structure, the resource availability, the coverage, and so on and so forth. I mean, so future work on effectiveness, I would maybe hand over to the next speakers, because they are actually really looking into how our database can be used to make statements about effectiveness.
Indeed, I think that makes a very nice link to the next presentation. So thanks a lot, Daniel. So this first presentation provided an overview of the CAPMF database. And now we'll have three short presentations that will show interesting applications and what type of results we can obtain with this database. So for the first presentation, I'd like to invite Filippo Maria D'Arcangelo from the OECD Economics Department. He's an economist and focuses mostly on climate change economics. Filippo, please.
Thank you very much, Elisa. While I try to share my screen, let me say that I will try to address partially the problem of effectiveness of policies. I'm not sure I will be able to answer entirely the question of whether we can causally relate the CAPMF to the effect on emissions, but I'll try to make some steps in this direction. So very briefly, I want to present this work joined with Tobias Cruz and Mauro Pisu on identifying and tracking climate change mitigation strategies. So what do we do in this paper? We identify archetypes, what we call strategies of mitigation policy mixes, employing the CAPMF. In particular, we are using the raw data of the CAPMF rather than the stringency values. And we apply a data-driven, unsupervised approach to try to make sense of the multidimensionality of the CAPMF and provide synthetic information that can then be used for policy evaluation. So in this paper, we first identify the strategies, and then we document how these strategies have evolved over time. And in particular, we looked at the past 20 years of data to characterize how countries have evolved in the way that they mitigate climate change. And finally, we shed some light on the synergies and trade-off of mitigation strategies. In particular, I will provide some suggestive evidence of the role of comprehensive policy mix, trying to address the question of whether many policies are more effective than few stringent policies in reducing emissions. So here I visualize the 50 countries that are currently covered by the CAPMF, and I divide them according to these four main mitigation strategies that we identify with the clustering approach. And on the right, you see a way of analyzing which are the common patterns within a strategy and the differences across them. In particular, we divide, we group policy instruments according to categories that minimize the difference between a strategy or a cluster and maximize within a strategy or a cluster and maximize the differences between. In particular, you can see that countries that have adopted what we call a strategy 1 mitigation strategies have comparatively modest coverage and stringency of their policy instruments. And in particular, they focus on subsidies and on the industry sector. That means most of their policies are geared toward the manufacturing sector. Strategy 2 is characterized by rather focused policies, although with wide heterogeneity in stringency across instruments and also across countries within this strategy. In particular, they adopt generous subsidies and in some instances rather ambitious emission trading schemes, but they tend not to have adopted carbon taxes, or they do with a rather low price. Strategy 3 is associated with a comprehensive policy mix. We find in this strategy countries that mostly Eastern European countries, and that have adopted a wide number of policy instruments, although generally with a lower stringency than other countries that we observe in the data set. And in particular, some key policies like carbon taxes and subsidies are not as stringent as in other countries. And finally, in strategy 4, we observe the countries with the most varied policy mix and the most stringent policy mixes to date. Something that is important to point out at this stage is that this exercise is made possible by the fact that we observe a level of stringency, even if it's a de jure stringency, meaning a by the book stringency, and it wouldn't be possible just by looking at which policies have been implemented or not. Next, I want to talk about how the adoption of these mitigation strategies has evolved over time. And my message here is that on mitigation, policy windows open fast and are seized fast. If we look back 15 years, we see that virtually any country covered by the CAPMF was adopting the same mitigation strategy that is the equivalent of strategy 1, the least ambitious one. And then starting from 2005, and in particular from 2010, countries have increasingly adopted different strategies and have started to separate in the approach that they have to fighting climate change. My next message regards the evolution over time of policy stringency. Some of this has been touched by Daniel, but I want to give you a different point of view on this. And in particular, I want to show you how, by looking at these different strategies, we can see diverging trends along certain policy instruments like carbon taxes, ETS, and bans and phase-outs, with some countries increasingly adopting stringent policies and other countries not adopting them at all. We also observe some common trends. This is particularly true for the adoption or the evolution of climate institutions and the adoption of international commitments from starting from the Paris Agreement. And finally, we also observe some parallel paths where every country is virtually on a strategy that increases policy stringency, although strategies that are in a sense laggard have not catched up with strategies that are in a sense leaders. My final message is on the complementarities between policies. So I will spare you the details, but we perform econometric analysis on the data relating emissions, and in particular emission reductions, to the level of stringency. There were some questions on the effectiveness, and this tries to at least provide correlations to substantiate the relationship between stringency and effectiveness. But in particular, well, we observed that emission changes decrease when stringency goes up. This is nothing new, but is reassuring in a way. But also importantly, we provide this suggestive evidence that more comprehensive climate strategies are more effective in reducing emissions. In particular, the statistical relationship between policy stringency and emission reduction is stronger for strategy 3 and strategy 4 countries, suggesting that there may be policy complementarities in these rather comprehensive policy mixes. this concludes my presentation. I invite you all to check out the working paper, and I hand it back to you, Elisa.
Thanks a lot, Filippo. That's a really interesting application. There is a clarification question for you on how you group the countries. Some countries are grouped while there is a distance. For example, China, Japan, and Canada seem to have different strategies. If you can explain that a bit better.
Yes, I skipped the technical details, and this question allow me to at least give a glimpse of that. So we have this cluster analysis. This is data-driven. It looks at the stringency along all the 110, 120 policy instruments, and then groups countries together according to the stringency, trying to minimize the differences within one group and maximizing the differences between groups. So the countries that get clustered together are clustered together because they have adopted the same policies, and also they have adopted the same policies at a similar level of stringency.
Maybe another quick question. Do you have plans for additional work using CAPMF at the economics department?
Yes, very much so. This paper is a stepping stone towards possibly more nuanced work. Here we are only looking at country level data. Instead, we would like to see what the effect of these climate policies that are effectively structural economic policies have on firms and households. And in particular, we have several projects open that uses the CAPMF as one of the important variables in our analysis. And one that I want to mention looks at how firms react to different types of policies in their decision to innovate, and in green technologies in particular. And having this rich data set, I think it's a good opportunity to look at what are the underlying causes that brings firms to do that.
All right, thanks a lot, Filippo. We'll move on to the second presentation, and I'd like to invite Nicolas Scott, who is the head of the Policy Evaluation Lab at the Mercator Research Institute on Global Commons and Climate Change, to start his presentation. Nicolas, please.
Yeah, thanks a lot for having me. You should see my slides, right? Okay, I'm going to present a joint work with colleagues from the Potsdam Institute, Mercator Research Institute, Oxford, University of Victoria, and Daniel Nachtigall from OECD. So that's a paper basically taking the CAPMF to understand really what from all those policies we have seen has worked in terms of reducing emissions. Which is, of course, empirically a challenging task. So let me guide you through what we do in the paper. So the starting point really is like you have seen with this database, we see it very clearly. We do have decades of experience with quite a diverse set of policy instruments, climate policy instruments, but still there's no consensus in science, no policy, which type or combination of policy instrument really reduces emissions at a larger scale. And I think part of the challenge is that our empirical research is very much focused towards evaluating the effect of a few headline policy instruments, which are super important. Carbon pricing is one of them. But then it also means countless of other policies are still sparsely or not evaluated at all. And this is especially true in the more developing country context world. So what we try to do in the paper is to really start with this entire spectrum of climate policy instruments that you've seen in the prior presentations at the global scale from the CAPMF, to generate then data-driven, and I would say data-driven causal hypothesis about policy mixes that have been successful in achieving large emission reductions. Okay, I will come back what I mean with causal hypothesis. bear with me. So our starting point, I have to be, for a few minutes, I have to be a bit technical to give you some idea what we are doing here. So the starting point is like that workhorse model of policy evaluation, I would argue, the difference framework, where we usually have focus on a single policy. We know when this policy acts, and this is what you see in my figure. We know when it is implemented in a country A. We know that country B didn't have this policy. Then we do our empirical strategies, and we try to estimate this policy effect, which is this tau in my equation. For those that know it, what I want you to understand is that basically these treatment effects we estimate in this workhorse difference and difference models is basically just a step shift in the unit, in the country fixed effect that we have in our model. This is highlighted in this reddish formula here. So we are usually looking for these step shifts, okay? So this is what we use. We are a group of like people that like econometrics. So we thought, why don't we flexibilize a bit the difference and difference framework? And you don't have to understand the math. Our simple idea is we have these countries, and our starting point is we allow everyone to be potentially treated by a policy at any point in time, okay? So this is in my figure. We have these two countries, country A and B, and at any point in time in both countries, emissions could jump down. These are the bluish lines that I have. Okay, so this is difficult to estimate, but then we have machine learning. Machine learning is very good to do, to select variables that matter. So we then use machine learning tools to select those step shifts, reductions in emissions relative to a control group in this difference and difference framework that were large. And large in our setup means something like emission reduction of 5 to 10%. And then we take the CAPMF and see, we have started without any policy, right? We first look for these step shifts and then look, okay, we have detected something here. What were all the policies behind it? And this is where the CAPMF is really powerful in helping us. And then we try to evaluate what we can learn from there. And this is what I want you to show. So with this method, we basically detect these 69 success cases all across the globe. Basically, the different colors of these boxes are the different sectors: building, electricity, industry, and transport, where we detect large emission reductions, okay? And then basically behind that, and I'm aware that you don't see a lot, I just want to show to clarify, behind that we have these like 69 case studies now about what did happen to emissions, how much were they reduced, where would emissions be if there were no policy intervention. And I'm picking out now just one, and this is in industry China. I'm just picking this one out, which is showing you here what is happening in these kind of models we are estimating. Like in black, you see the actual emissions, and in blue, our model of these emissions. And then the red line is how emissions would have evolved if there hadn't been a strong emission reduction in 2016 here that we estimate our model, which, and that's the colored boxes on the bottom, come together with important policy interventions, in particular the introduction of the 7 pilot emission trading scheme in China. And we basically detected emission reductions that prior papers have already found. And this is true for like many interventions. We basically detect what others have found, but often we also highlight, well, it has not only been the ETS systems, but also other policies that were also there. So the key question is, was it only the ETS? Did the other policies play a role? Learn something about the importance of policy mixes, which instruments work together well. That's that's basically why we have these case studies, to learn about that. One way to learn that is, again, a busy figure, but it's showing two simple things. For each of the 4 sectors, there are all the policy instruments that are relevant to some, and then we aggregate them to some extent here. You have all those policy instruments that matter, and then you see 2 bars. The dark bar is the emission reduction effect if the policy is part of a policy mix. The light bar is if that policy comes alone. And now what we can learn, and I highlight this by these black and reddish boxes, is we have a bunch of regulations and a bunch of subsidy schemes. So here, for example, the adoption subsidies in buildings, the performance standards, the labels in buildings, or the ban and phase out in the electricity sector, where we never detect a success case, a strong emission reduction, if that policy instrument comes alone. But we detect it if it is part of a mix. And the black line in that on that policy mix effect size is indicating whether carbon pricing was involved here. And what you basically see, that we have this like really large set of regulations and subsidies where we detect no effect or a significantly higher effect if the policy comes together with carbon pricing. Okay, so pricing, what we learn here is from that comparison is that pricing is often a complement enabling large emission reductions. And then we also have these Venn diagrams showing the overlap of different policy types, pricing versus regulation versus subsidies. And we can basically learn pricing is particularly effective in those contexts where you have profit maximizing firms. So electricity and industry sector in the developed economies, while in transportation and buildings are more complex. You have more complementarities in that sense because you have private consumers that we know from the literature are subject to behavioral biases. So bottom line of our study is, in general, we find that emission reductions on a scale that matches zero emission targets are possible, but we need to scale them up. To do so, we want to think about pricing as a critical element in an effective policy mix. At the same time, we want to be aware that this one-size-fits-all approach is unlikely to work, but really we want to think about sector country-specific best practices. And I'm stopping here, given time.
Yes, thank you very much. Thanks a lot for a very nice presentation. There's a clarification question asking if you can explain a bit better the variable selection methods that you use.
Yeah, so the one we use is called GATS. So what is really nice about GATS is you can control the false positive rate. And that's important. False positive rate, what does it mean? We know we can control how stringent we want to be, that we find an emission reduction, which de facto is not 1, right? So we are very conservative here and set it to 1%. So this is really nice because we think that whole approach is only credible if we are conservative. But you can also use, like, we also have in the paper a version with Lasso, which is the more known algorithm, I guess. But Lasso is really, it's very hard to get Lasso to make Lasso conservative. So we think this GATS algorithm that the Oxford people have developed over a long time is really powerful in that application here.
Right, thanks a lot. There is also another question on the China case study. I guess the idea is wondering whether there were any surprising results or your thoughts about causality in that specific case study.
Yeah, I mean, surprising results. I mean, it was basically not so much in the case studies per se, but it was really I think, quite surprising to consistently see some of the policy instruments like bans and phase outs. We consistently see them, we detect them. If they exist, we usually detect them. But then we have this very strong evidence that they never come alone, but come in this package. And usually the thing that makes the package effective seems to be carbon pricing. I mean, it's a first investigation in that direction. There are still empirical challenges, but like the overall pattern here, how clear it was, that was surprising to us, I would say.
All right, thanks very much, Nicholas. Conscious of time, I'd like to invite our last speaker to present. Our last speaker is from the World Bank. She's a senior economist at the World Bank and a research associate at the Institute for New Economic Thinking. Penny Mealy, the floor is yours.
Thank you so much, Elisa. Can you hear me and see my slides okay?
Yes, all good.
Terrific. That's great. Well, thank you very much for having me. It's really great to have the opportunity to be part of the discussion, and I've certainly learnt a lot already. I'm going to be presenting our work with wonderful colleagues, Michael Ganzelmeyer, who's from Oxford, Katrina Godino, who's at the New Climate Institute, and Stefan Hallegatt, who's also at the World Bank with me. I'm based in the climate change group at the World Bank, and one of the things that we are endlessly mindful of is the fact that since climate change is such a global issue, climate policies will need to be introduced in countries all around the world. And the huge challenge, of course, is that every country is different. Every country faces unique institutional, contextual, and political challenges that shape their current space of policy possibilities. And so while policies can be a lot easier to recommend, when it comes to their implementation, that can be a lot more challenging. So, even though a policy may be wonderfully justified with sound evidence on the cost of benefits, the effectiveness that we've heard a lot about today, when it comes to the practical reality of a country's operating environment, its institutional capacity, and so on, some policies are just simply less feasible to introduce than others. And so one question we've been thinking a lot about is, what if we could design and recommend policies differently? What if we could actually chart out the space of policies that are more likely to be feasible and realistic for countries, and try to limit our what we often do is to make often idealistic recommendations about what countries ought to do. And so to do this, we've created what's called the climate policy space, which looks something like this. Now, sorry if this comes as a slight disappointment, but for the analysis I'll talk about today, we're actually not using the CAPMF database yet, but I can assure you it's coming and work is well underway. We're very excited about the possibilities of this database. This particular work I'm showing you comes from the climate policy database developed by New Climate Institute. And we've largely used this database initially because as the World Bank, we are primarily interested in low and middle income countries. And so we needed a database with a bit more coverage across these countries. But Daniel tells me that greater coverage of low-income countries is very much in the pipeline. And so we're currently in the process of undertaking similar analysis, what I'll talk about today with the CAPMF database, with the anticipation we can also extend this once the geographical coverage is a little bit wider. But let me quickly explain this network diagram. So here, each node represents a climate policy instrument. So you've got carbon taxes, feed-in tariffs, and emission reduction targets, and so on. These policies are linked together here on the basis of our observations of their co-occurrence within countries. So if two climate policies frequently co-occur, and we can observe that actually a country has introduced one of them, but not yet the other, then we can make assumptions about how likely it is that other policy would be feasible, and whether or not it requires similar underlying institutional capabilities. to introduce it. Now, I've coloured policies by how commonly they've been introduced across countries. And you can see that some policies, like non-binding targets, climate strategies, and things like strategic planning, have been quite commonly introduced, indicating that things are possibly relatively easy to do for countries. Non-binding stuff doesn't actually commit you to do anything, but other policies in dark orange show a lot of the stuff in the top of the network relating to technology development or carbon taxes or the removal of fossil fuels have been introduced comparably less frequently. When we look across countries of different income groups, in some sense, it's not particularly surprising to see that, higher income countries just have introduced more climate policies. But it is more interesting to see that there are distinct patterns in the way that that different income groups have introduced these policies in certain areas of the network. So low income countries that are likely to have less developed institutional capacity tend to have they tend to introduce more commonly non-binding strategy types of things in the bottom of the network, while the kind of lower and middle income countries, you see them spread out a little bit more in this middle region of the network where we've got more regulatory and market-based types of instruments. And then the higher income countries, you see them spread out in the top region of the network as well. Many of these policies relate to technology and innovation. We can also see that over time, countries have a strong tendency to successively introduce policies that are nearby to climate policies they've already introduced in the climate policy space. And this suggests that policy adoption is probably a highly path-dependent process. It's intuitively much easier to introduce climate policies that require similar types of institutional capabilities and know-how to what you've previously done before. So a key question we were interested in is whether we could exploit this path dependency to predict future climate policy adoption across countries. And in a nutshell, yes, we can. We constructed a measure of policy alignment between a specific country and new policies that they haven't yet introduced, based on the conditional probability of adopting a given climate policy, given all the policies a country has prior experience with. And so we calculated this based on the data up to 2015 and then tested its ability to predict policy adoption in subsequent years. We find that indeed countries are significantly more likely to introduce policies that are more aligned with policies they've previously introduced, even when we control for a bunch of various economic policy and climate variables and played around with different functional forms, data timeframes, prediction windows. This thing tends to be fairly robust. So then based on this measure, we've then used it to construct what we've called climate policy feasibility frontiers across country. So here I'm just showing you an example of Turkey. On the left-hand side of the figure, I'm showing you the climate policy network space for Turkey, where the blue policy nodes represent policies Turkey has prior experience with, while the grey nodes are policy instruments Turkey has not yet had any policy history in. Of these grey nodes, we're highlighting a few ones in the black circles where you can kind of see in the network that they're close to things that Turkey already has a lot of experience with. So things like a legally binding climate strategy or a legally binding emissions reduction target. And these sorts of policies are likely to be more feasible for Turkey to introduce. And on that basis, we're kind of showing our key measures on the right-hand side of the plot, which on the x-axis, we're showing our measure of policy alignment. So you can see the bubbles of different climate policies. The ones further on the right-hand side are the more feasible ones for Turkey. And on the y-axis, we've calculated a measure for how strategic these policies are in terms of expanding your capacity to introduce more policies in the future. So policies you'd ideally target are in the top right, which are more feasible, but also more strategic in terms of opening up the capacity to do more ambitious policies going forward. And this provides, just a nice little tool for sketching out a strategic sequence of feasible policy stepping stones that countries can follow. Now, the other thing, of course, it's always nice to say something about the effectiveness of these policies in terms of the emissions reduction potential. We haven't done anything near as sophisticated as what Nicholas did with the CAPMF framework. We've just followed a slightly different methodology based on a paper in climate change, but it just gives you an indication of the types of policies that we can expect to be more effective in terms of their emissions reduction. The beautiful thing is we can look at feasibility frontiers for any country. This is Vietnam, just for example. And certainly at the bank, our goal is really to start experimenting with this as an additional lens to start looking at the policy recommendations we're making for different countries and asking the questions, are these actually feasible? If not, what is a sensible and strategic policy sequence that could help a country achieve its climate goals? So I know I'm rapidly out of time. So very quickly, to wrap up, climate policy feasibility frontiers can help countries more strategically prioritize and sequence climate policies and allow us to chart out feasible pathways towards more ambitious action. But of course, one of the key things we're missing here from the climate policy database is information about policy stringency. And so with Daniel, we are, as I mentioned, currently working to expand this work with the CAPMF database, and I look forward to sharing you results when we're a little bit further along in that process. Over to you, Elisa.
Thanks a lot, Penny. And I guess this was like an appetizer to then come back and see if the results change once you use the CAPMF database with indicators. There's a clarification question for you, which is from the climate policy database. What are the most and least frequent climate policies adopted overall in the almost 200 countries covered?
Yeah, so if I just go back to the slides, you can see this one here where I've actually colored in purple the ones that are the most frequently adopted across countries. So you can see a lot of the non-binding types of policies, strategies, targets, things that are announced for NDCs and so on, do tend to be the most commonly occurring policies across countries, which kind of, makes sense if you think about the political effort or the institutional capacity required. As I mentioned, these things I'm not saying they're easy, but they're comparably easy to introduce relative to something like a carbon pricing policy. Yeah, I'll end there.
All right, thanks a lot. Now we have about 20 minutes left for a Q&A session. So I'd like to invite all the speakers to turn on their cameras so we can have a more interactive discussion. And to start with, I was wondering, given the questions we got in the Q&A, I was wondering if you can comment about the link between stringency and effectiveness. Is there a causal relationship between stringency and effectiveness from the applications you've done? Daniel, maybe you want to start?
Yes, I can start. Many thanks for that question. So I think Nicholas is probably later on in a better position to answer that. But kind of if you just look at the CAPMF, so there is certainly not like a causal relationship between effectiveness and stringency. So all we do is, and that's kind of by design already, all we do is that we see what is the policy intensity that is in law, and that then of course translates into changes of behavior, and then also into changes in emissions. But that all that reaction chain is extremely context dependent. So in a way, we cannot make like a statement that higher stringency automatically will result in higher effectiveness. And in a way, yes, in a way, you can actually even make the point that there could be reverse causality, that countries that have already that see that, for example, for cultural reasons, that they have managed to reduce their emissions a lot, that they might need less stringent policies. So I mean that we cannot exclude. But what we can do is that we provide the data, And researchers like Nicholas or Penny, they can use the data and can combine it with emissions data, and then they can tease out or can analyze the questions to those questions, the answers to those questions. And I don't know, maybe Nicholas can complement here.
Nicholas, you've been put on the spot.
Yeah, sure. I mean, I can first of all only agree with Daniel. I mean, the way we work with the data is we for us, if it's an adoption or an increase in stringency, I mean, we are a bit strict here. We say stringency must increase to some extent. We are agnostic about whether that's an adoption or an increase in stringency. But I think it's a combination of both that in general, in that like what we have studied is very important to work. And then at the same time, we have to acknowledge that like there are like countries, context specific determinants and probably heterogeneity that we haven't studied in the study because it was more like the whole approach was about learning from the global success cases, something bigger about these policy mixes. So I think there's still room to better understand it. But based on what we have in the analysis, it certainly both matters.
Thanks a lot. Filippo, please.
Yeah, just to add maybe a consideration on all of this, and building on what Daniel said about this data set can be used to then establish effectiveness and establish how effectiveness is moderated by other country-specific characteristics or institutional setup, some of what Penny has showed us. What I wanted to say, I think, as researchers, we are always in search for establishing a reasonable or credible causal link, and that is a challenge per se. What the CAPMF offers us is that it offers something that is comparable across countries, and everyone that has worked with cross-country policies knows how how difficult that is. At the same time, it's incredibly important because if we want to accelerate on climate change, we cannot lose the learning opportunity of countries that have already experienced certain policies and see what those policies have worked and what have not to then implement them where needed. So this cross-country dimension is very important. And so far, there's some other data sets, but the CAPMF is I would say, is one of the few that does it with such a large coverage and consistency, and that offers us stringency values, which is quite important, I think.
Thanks a lot, Filippo. Basically, Penny, Filippo already mentioned it, that you raised a little bit about the institutional framework as well and context. So we've mentioned stringency and effectiveness, but do you think there is also a role for enforcement in the whole steps from policies to actual emissions reductions?
Yeah, I mean, it's something that certainly isn't in the data that we've used so far, and will be fascinating to better understand, how feasible enforcement is in certain countries. Different. Oops, am I breaking up?
No, can hear you just fine.
Okay. How feasible enforcement is in certain countries and different contexts, and whether as from a political economy perspective, introducing a very stringent policy that's heavily first up makes it just challenging to introduce it at all, or whether there's an important strategy of kind of like, I guess, the foot in the door kind of thing, where you firstly introduce policy at a relatively low stringency level that ramps up. Enforcement is maybe less strictly applied, and again kind of has this ramp up approach as compliance with that policy becomes more accepted and also more easy. I mean, I think the result on the complementarity between carbon pricing and other policies is so key. I mean, I think pricing, when you price things and you send signals for like technology development to occur and prices of renewables fall, then complying with a given policy is just easier, it's cheaper. And so all these things, I think, start moving together, which is kind of what we want, which is great.
Thanks a lot, Penny. Maybe just to the attendees, I want to say we're trying our best to answer in writing or pick up on your questions live, but there's a lot of questions, so please be understanding if we don't manage to address them all. I thought there was one question that was very interesting, which was on whether you thought that this type of work, both on the database and the database application, would be extendable to adaptation and not just mitigation, and possibly also to other environmental issues. Don't know who wants to start. Daniel, on the database?
So yeah, I can start. So I think in principle, it is probably possible. I mean, if we talk about other environmental spheres, I mean, then kind of certainly, because I mean, climate change is only one of the big environmental topics. I mean, we have also biodiversity loss, where we can, in principle, kind of use a similar methodology. With respect to climate adaptation, it is actually certainly more challenging, and it is more challenging because adaptation is, so first of all, I think kind of the metric of success for climate adaptation is perhaps not 100% clear. I mean, for climate mitigation, it is essentially reducing greenhouse gas emissions. For climate adaptation, it is probably something like reducing risk, but risk is also like a very multidimensional concept as such, so that is already challenging. And then the second one, which is even more challenging, is that adaptation is really extremely context specific. So to that extent, you know, I mean, we don't need to talk about flood risks for, flood risk from sea level rise for landlocked countries or something like that. And I mean, of course, there are also like methodologically, there are also ways around it, but I really see that as a major challenge.
I would agree. The indicators are more difficult for adaptation. Although there is progress in the measurement also for adaptation that can help. Does anyone want to add something on? Yeah, Penny?
Maybe if I can just add, I mean, certainly at the World Bank, because a lot of the country, our client countries, you know, for them, they don't emit a lot. So mitigation is lower on the priority list, but adaptation is so important. So it's certainly a focus, a huge focus for us. And the data is, as Daniel mentioned, definitely less developed than mitigation. Even like a typology of adaptation, is it policies or is it more like actions, is actually not readily available in a way that is, I think, able to be tracked in the same way that you've done for CAPMF. So I think there's a huge need for more work in the adaptation space on typology, on thinking through, you know, how do we measure, as Danny mentioned, success. Incentives are very different for countries to adopt adaptation actions than compared to mitigation policies. The political economy questions are also very different. So I think it's a really rich and super important space that I hope many researchers on this call will start thinking about.
Thanks a lot, Penny. I guess another issue that countries are often worried about is the link between climate policies and economic performance, with the idea of reducing emissions, of course. So do you think there is scope to assess the effect of climate policies on economic growth, whether it's positive or negative? I guess maybe we can ask a representative from the economics department here.
Happy to answer this. So there's a long history that dates back decades in the economics department in trying to understand what is, and not only in the economics department, admittedly, at the OECD, but that tries to understand what is the impact of climate policies on economic growth at a macro level, but also on economic performance at the micro level. Does this impact productivity in firms? Does this increase costs? Economic theory give us pretty straight predictions on how different environmental instruments, climate instruments fare in terms of the abatement costs that they impose to firms. And what the CAPMF offers us is a very rich database that can be used precisely to investigate these questions, possibly employing micro level data to address more credibly those causality concerns that we were discussing before, but also offers us the possibility to do that in a cross-country setting. And this is precisely what is in the future for us in the economics department. We want to unpack how different climate instruments fare in terms also of economic performance. There was a question related to growth and one about economic efficiency. This is very key. If we want to progress in climate change mitigation, we ought to do it, and we ought to do it at the minimal cost for firms, for households, for governments, and so on. So definitely, this is in plan for us.
Thanks a lot, Filippo. Maybe one question for Nicholas that I thought was interesting, in the sense that, we're talking about economic performance, and sometimes things work, sometimes things don't work. Is there anything we can learn from your paper on policies that did not work?
Yes and no. Because we are not estimating the focus of our paper is to detect large emission reductions, and this translates roughly to more than 5% emission reduction. So if we don't detect a policy or a combination of policies, it doesn't mean it didn't work. It just means it didn't reduce emissions to a larger extent. And our focus is it has methodological reasons for us to focus on that. But also for the climate, right? That's what matters. Why we really want to think about interventions that reduces emissions at a larger scale, because this is what we need to achieve our quite ambitious targets in many regions of the world. So our paper is very clear in terms of which policies do not deliver large emission reduction. Yes, but it doesn't mean no effect. It could be 1%, 2%, 3% emission reduction. But yeah.
Thanks a lot. Well, we're getting towards the end of the webinar, so I'd like to suggest that each of you can maybe take a minute to just highlight something you'd like to say that you think is important to highlight. Daniel, do you want to start?
Yeah, sure. So I think kind of also going back to one of the questions that was in the chat about kind of how does the CAPMF compare to greenhouse gas emissions? I think kind of there's maybe a misunderstanding about the goal of the CAPMF. I mean, the CAPMF is certainly not a performance metric, and we shouldn't use it as a performance metric. So it doesn't mean that if a country scores well in the CAPMF, that it is better than another country. That's certainly not. But I think what I hope that really that seminar made clear is that, first of all, none of the case studies really use the CAPMF as a performance metric. And what is actually even more important is that the granular data of the CAPMF can be really used to analyze policy questions that are really very important at the moment. So how are we able to reduce emissions? And that's what we are trying to provide the data for.
Thanks, Daniel. Filippo?
yeah, maybe I want to give one suggestion and one comment. One suggestion is that all of us, we have discussed the use of the CAPMF in aggregate, looking at different instruments, but this is a very rich data set in itself. If you're interested in one of the specific instruments that are there, I still invite you to go look at that. And they get aggregated in policy instruments, but the team, Daniel's team, has put out also the raw data, and so there's just a bunch of information that is ready to use and is very precious. And the second thing, I don't think Daniel has stressed this enough, but they validate all of this data by bringing them to countries that then discuss with them, sometimes quite harshly, and there's the ministries of environment that say, okay, this has passed a reasonable check. And typically you do not have this from other data sets. I don't know why it doesn't stress this more, but this is very, very crucial, I would say.
Very true, and he's very patient. He's been doing a great job with trying to mediate. Nicholas?
Yeah, I want to strongly agree with the last point. That was also a major benefit we saw with the data. I mean, what I would like to highlight still is that I think this kind of data that you now pile together is so crucial also for like international processes like the IPCC assessment in the next assessment cycle, where we had seen in the past like evaluation of policy instruments that have been quite general. You could, I always say I could equally read a textbook on environmental economics. I would read very similar things than the assessment on policy instruments in the assessment reports. I mean, I'm a bit simplifying here, but I think now with that kind of data that you have put out there as a public good, like people can jump on it. We're just one team, and really do our best to really improve, to learn from that data about effectiveness, what works, what does not work, like these questions that are so crucial and that need to be at the heart of discussion about mitigation policies. So my hope is that this is really an enabler also to see more insightful, deeper discussions on policy instruments in processes like IPCC. I think this is great.
Thanks a lot, Nicholas. Fanny?
Yeah, no, I agree with everything that's been said. I do think this is an incredible public good that I knew was particularly costly to develop. We're really excited to see it out, and also the plans for extending it to more countries is really exciting on our end. I think one of the interesting things, I mean, sort of to echo what Nicholas was saying with the IPCC types of analysis, often like with modeling in particular, you just have a policy scenario and then all the modeling is around the effect of that. But not often you think about the actual, feasibility of the policy or the effectiveness of that policy in that process. I think this offers a much richer evidence base to take some of that analysis forward in a more rigorous way, which is super exciting. So yeah, let me just say thank you from the bottom of my heart for putting this together. It's going to be make an incredible difference, and will continue, I think, to improve the ability to do climate action all around the world. Thank you.
Thanks, Benny. And as a modeler, I would support what you just said. I think this type of database and the related empirical applications could also really improve the ex-ante type of policy analysis. But I'd really like to conclude with thanking all the speakers. Great job in explaining technical content in a very accessible way. It was very interesting. Thanks a lot to the participants and for the very interesting questions. So with that, I'd like to close and wish you all a nice rest of the day. Bye.